So, hello everybody. I hope everybody's doing good. My name's Chad, as can be seen on the slide over there. And I'm a backend engineer at Luno, particularly a Golang backend engineer. And actually today is my 1-year Lunoversary at Luno as well. Little fun fact. Yeah. I'm all the way out from South Africa, and I'm based in Cape Town, so I flew all the way out here to come and have a nice chat with you guys and get to know all of you guys and meet up with you guys. And yeah, this is also my first time talking in front of people, so please do be patient with me, and I'll try my best to bring across my ideas as best as I can. So today we're going to just be talking about how at Luno we tried scaling our monolith that we had in the past, and along with Go and a few kind of little ideas and sort of ways of thinking, we try to make it more scalable and handle the sort of loads and that we kind of faced with. All right. Yeah, so this photo was taken at a winter offsite at Luno, and just to show you who we are as a people. And so who we are, I don't know if anybody know about Luno. We are a cryptocurrency exchange and wallet, and what our vision is primarily is to kind of upgrade the world to a better sort of financial system. Because for us, we believe that cryptocurrencies kind of represent the next stage of our evolution when it comes to money. And we currently headquartered in the UK with offices in Singapore, Indonesia, Malaysia, and Cape Town and the likes. And our customer numbers at the moment is 2 million, and we're trying to 10x that at least in the next 5 years, so that we can at least handle like 100 million customers. And part of our goal is to kind of be one of the top 5 cryptocurrency companies in the world. So yeah, so we're scaling and we're growing really fast, and we're really trying to kind of be a champion in this sort of domain. So just to go over the little agenda of what I'll be trying to talk about. So as a startup, I want to first talk about how we kind of built out our first versions of our app and try to get it into the hands of the people, and also try to talk about the issues that we faced with our first version and the considerations that we needed to take into account in order to redesign what we had. And then briefly kind of paint a picture of what microservices are for those who are not familiar with the concept, and then kind of explore our approach in terms of trying to scale what we had and make it kind of handle the issues that we faced. So key takeaways is just to kind of see how we went from this mono to micro kind of paradigm, and the principles we kind of picked up and practices we picked up along the way, along with our approach to structuring our packages and how we think it kind of makes a little bit of sense in our context. Yeah. So just to kind of give you an overview again of what a cryptocurrency exchange is, because I mean we are a cryptocurrency exchange. So essentially it's just this concept of having customers using our application and exchange, and there's sort of a blockchain network out there, and there's also some sort of bank out there as well that we try to kind of keep in sync with these sorts of things. And we offer the ability obviously for customers to deposit fiat, or such as the pound and sort of various other currencies, as well as interact with the Bitcoin and Ethereum and kind of manage those sorts of balances between the two that a customer might have. So now with that in mind, when we started building the first version of the app, we kind of needed to make a few design decisions to kind of get something out quickly as possible that is simple yet robust and secure. And when we started off, we tried to kind of build it out, thinking out, okay, what are some bounded contexts that we can actually think of at the moment? This is a complicated thing, so let's just kind of keep it simple and figure out those sort of contexts so that we can easily reason about it, easily understand it, and so that it can also offer sort of an ease of development and maintenance for our small team that we had at the time. So this kind of led us down the path of choosing Go. There's various reasons for that in the crypto space, being that there's a lot of support and a lot of cool tools out there that we can use. And we used a monorepo to go the way we structured our application. Also using some Docker stuff for containerization, and then hosting things on AWS, and try to use as much tools as we can as possible. So at the time, we had a few sort of subsets of things that we wanted to build out, and we kind of broke it down into these sorts of 3 areas. One being API, and that service we primarily try to deal with public API requests, our mobile application trying to speak with our backend, and as well as any sort of web traffic that we were trying to have. And then we had Matcher. So essentially Matcher was pretty much just this exchange of allowing people to buy and sell cryptocurrency. So it tries to match a buy and a sell so that people can actually transact with each other. And then Sync was this other service that we try to build that, in essence, try to keep itself up to date and integrated with banks as well as blockchains. So monitoring what's happening on the blockchain, checking out if there's any of those transactions on the blockchain that belongs to our customers, and try to pair that up with sort of the data that we hold and the state that we hold in our system. But in so doing, so this is just a beautiful picture of how that kind of looks like. And as can be seen, all of this in our initial version of our app, because we wanted to get to market quickly, we didn't know if there's really a market or if we even have any customers. So it's pointless going and being crazy and spending a lot of time building out things that are complicated. And we just tried to leverage off of things that we can on AWS and kind of had everything piggyback off of like one MySQL DB instance. But then the issues that we then encountered with all of this. So most of the issues that we encountered, I don't know if you guys can recall the price surge during the December period when Bitcoin just skyrocketed. And during that time, everybody wanted Bitcoin and everybody wanted their hands on it, and they came to us, especially in the markets that we were operating. And we started noticing that our central DB that we had and these 3 services that are then using the central DB was starting to give us some sort of issues. We had some expensive queries that we're executing on it. Some memory issues if result sets coming back was a bit too large. So there was a lot of sort of fundamental sort of issues that we were facing with this sort of setup that we originally had. And it had us kind of probe the question of, okay, now we need to really redesign, really rethink what it is that we have, what it is that we want to have, and also just a path of getting from where we are to where we want to be. So essentially, the Sync service that I mentioned was one of our biggest bottlenecks because it started kind of growing in scope. So part of what we had to do was monitor the blockchain, see if there's a transaction for a customer, bring back that sort of transaction, wait again for confirmations that there's enough confirmations, and then once there's enough confirmations, send out an email to tell the customer your transaction has been confirmed and then everything is happy, update our ledgers, and do all of these sorts of things. So initially, all of that was just baked in Sync and wasn't really the best solution. It worked at the time when we had very little customers, but once you start growing and scaling, this sort of idea doesn't work anymore. But the really nice thing of it all, I think, is that we got data. And we had some really good information of looking at how our systems are interacting with each other, where there's certain bottlenecks in our systems. And we could actually use that data to kind of figure out how we can actually chip away certain things in our systems to kind of be more optimized for our purposes. So after that, we looked at what we had and started prioritizing aspects of chipping away. And then along came this concept of microservice for us. So we had this problem, and the only way that we could think of really solving it was to start introducing this concept of building out microservices. All right, so what we had initially was sort of fundamentally in principle not really a microservice, but at least in terms of the structure and the way that we thought about it initially, it was kind of having some sort of flavors of it in terms of breaking out concerns and making sure that everything has certain things that it can actually execute. But it was all just relying on not owning everything in that time wasn't owning its own data, and everything wasn't really right. So we really tried to consider, okay, how can we do this? And after this, I'll try and elaborate how we started moving towards this direction. So before I do that, just so that we can probably be on the same page, for those who are new, but microservice essentially is just that. It's a development technique that we try to use to kind of break a big problem into smaller little problems that make sense, and then in essence, give them their own resources, allow them to own their own data, allow them to then interact with other things, and essentially the result of that gives the value that you want as a business. So it's essentially just these small fine-grained sort of single-purpose systems, and our organization needed to be ready also to embrace it, because you can't just say, let's do microservices, and your organization is not yet there for it. So we spoke with our engineers, and everybody was on board, and everybody was happy for it, and we tried to start doing just exactly this. And because we were using Go, it was actually quite cool, because there's some nice, cool, nifty things that comes with Go, like the standard library and all that allows us to easily, with not a lot of clutter and syntactic magic and stuff, build something out elegantly and simple enough. But so microservices in essence is, as you see, like this isolated thing, or a microservice is something that is in a box, like a black box. And it's isolated, it has its own data, it can do a particular thing, and it can do it pretty well. And a very important thing for microservices is to be able to communicate with other microservices, or in essence, a part of your business when you do this sort of strategy is to allow things to communicate with each other so that you can give some value. Because, I mean, storing customer data is not really a sort of a business that you can, or maybe it is, but in our case at least, it's not a business that we want to sell. So kind of boxing that into a microservice isn't really the end result of our complete application. So we need obviously a means of allowing things to communicate with each other so that we can give the value that we want. And so there's many ways of allowing things to communicate in a microservice environment. You can obviously use REST, or at least the paradigm, and obviously using JSON sort of messages to kind of translate value across your network. Or you could do things like with what we did and we chose is gRPC along with protobufs. So to allow microservice to communicate in a kind of bidirectional manner and easily be able to encode on client and server what it is that you want to actually transport across this network. And yeah, I mean, in essence, that is what we chose. So we chose up gRPC in the end. It's a cool RPC framework. And along with that, some protobufs to help us define all that out. There's still a but. So now that you have a microservice, or you've built out this concept of a microservice, and you've built out another concept of another microservice, and now they're friends and they can communicate with each other, we still need to know how to build it out. And I feel like, for me, that was one of the, especially being new to Go as well, that was one of the biggest things that I was wondering, how do you actually do it? How do I go about structuring things? How do I go about thinking about where to place things? And how do I go about making it happen? And I hope to kind of show how, at least at Luno, we've tried to do in terms of kind of keeping it simple and to have that sort of evolutionary kind of growth from what we had to where we ideally want to be, and kind of taking it one step at a time to get there. So before we could do anything, we had to look into what does the Go community say about this problem? Is there anything out there that people are talking about this, and what do they say? How do they resolve these sorts of issues? And there's some interesting, cool talks out there actually, and cool slides, and cool things that you can actually go and look at. And one being from Francesca, I don't know how to pronounce the name properly, and another being a cool Git repo that has some cool little principles and guidelines to help you sketch it out. And in a nutshell, the ones at the bottom is what we try to kind of, when you get new engineers or new gophers, or we're trying to build out microservices, we try to kind of enforce these sorts of, not really enforce, but kind of as a team abide by them as best as we can. And as can be seen, that's kind of creating functions that have a single purpose, and hopefully having them being idempotent, such that if it's living in a microservice and something wants to make use of that function, it can easily realize, it knows that there's no real hidden side effects, and that it can easily just know that if it failed or something, I can just call it again and would get a good response back later maybe. And then, as can be mentioned, functions that kind of follow a golden path as well. So in terms of reading and understanding, because we all need to go, well, I am at least, reading and understanding it needs to be able to be structured in a way that can be easily, that one can easily look at it with the eye and make sense of what it means. And the various others. Yeah. So essentially, this all boils down to just one key principle for us again, and that's just keeping it simple. We wanted to make sure that when we do this, or go through this process of migrating, that we want to, at the heart of it all, not like have a big bang or big shocking approach to it, but that at the end of it, that it still makes sense to us, and it's still easy to kind of go through and easy to reason about and understand. So in essence, what I want to actually talk about is our approach, and kind of breaking it down to what we thought was a good approach to tackling this problem for us. And it starts with step one. In our case, at least, we had a monolith, and we needing to break that down and kind of break it down into sort of microservices, because we have a problem with the issues that we're facing with our application. And thereafter, looking at, okay, now that we have data, because we have this monolith and we've kind of tracked data to see the sore points in our system, what aspects of it can we actually chip away? What aspects of it can actually form a bounded context that makes sense? And by that I mean like where I can add like a bucket, and the things that's in that bucket is kind of related to each other, and they kind of paint a nice picture of a sort of domain that makes sense. And then after that, just start building. And the nice thing from Golang for us, at least, is at the heart of it is, for us in terms of our microservices, this concept of the Go interface. And that, in essence, a microservice is just this black box that offers certain functionality. And an interface in Go is pretty much mirrors that. So it's a sort of type or something that has certain function, that functions, that takes in certain inputs and produces certain outputs. And at the heart of what our microservices are is just this sort of contract saying that our microservice offers these functions, and here's a little interface that kind of explains what it is. So everything that implements this interface within the microservice abides by that contract. And then the other thing again is piggybacking off this concept of we having a monorepo. And that means that everybody that's working outside of the context of that particular microservice could pry into your code and could make use of your code. But sometimes there's certain things that are, you could maybe call them like unsafe to use outside of the context of your microservice, that you want to have a sort of way of protecting that and hiding that away and making it just things that need to get access being exposed and nothing else. And again, keeping it simple. Yeah, so after doing all of that, we also wanted to add some metrics and kind of see if we can monitor if going from what we have to what we now are building and got, if it actually improved what our current situation is. So just a little overview. I decided to just put this in front just to show you roughly the categories in which we kind of broke things down into in building a little microservice. In essence, if this was an example of an exchange package, there'd be starting off with some good documentation. So every microservice deserves good documentation. So there's a .go file. And then every microservice needs the exchange.go file is where that contract is sitting in. And it says that this microservice has the abilities to do these things. And the metrics and types is just metrics again is just to do that monitoring that we want to know. Are we improving things? Are we making things more effective? The types.go again is around what is the things that we want to potentially allow others in this world to kind of have access to what we're using. And then there's various other packages that I want to jump into a little bit in more detail as we go along. Yeah. So, first thing in our approach is building out this domain, right? So, in the context of microservices, they kind of have a domain in which they sort of operate in. And what we wanted to do is we wanted to, in the root of our kind of package, put all the sort of domain types and domain things there. So that's very easy to access. Again, in the context of a monorepo, that's quite cool. Is if you're outside of that microservice and you just want to use the type of an order or something, the order type or something, you can just make use of it. And it must be very easy to access rather than exchange.order.type. It should just be exchange.orderType. And that was what we tried to do with our first step, is saying keeping it simple means let's put the domain in the root of our package. And the next thing again is, what's very important for us is this contract. And let's go and define that sort of contract. So we call it a types client, and it's an interface that has these, made some simple example, these two functions, get order and list orders. And essentially what this tells other microservices, at least, this is part and parcel of our SLA to you as other microservices, is we offer these functions, you can use us, and no matter how we implement it or no matter what we choose to do in the background, as long as we guarantee these functions, we're safe to go. And then what we then did was, because as I said before, we make use of gRPC along with protobufs to communicate between microservices, we then created another package, and that package is Exchange, in this case, Exchange PB. And the Exchange PB would contain the magical proto file that then defines the messages that are being transported across the wire, as well as the actual service functions that we are offering. So in this case, because of space, I just showed how the RPC functions are defined within the proto file. So again, this kind of exposes, or at least allows a client and a server to understand what it is that's going to be sitting between the client and the service, and how that communication is going to exist, and how that tunnel is going to exist, or pipeline is going to exist for them to communicate with each other. So again, in part and parcel of our approach, the next thing that we then did was consider, okay, cool, so let's actually add a client package. So a client package, because in our case, we want to have an implementation of that client sitting in our package. And we want to allow other microservices to say, hey, can I use your client to communicate with you? And so in this case, we created another package for it, because sometimes in our case, in our microservice, we might split it out into what we call as logical little services, or nano services, or however you might want to phrase that. And those small little logical services, they are sitting in this bigger microservice, and they might want to share, maybe they have a single DB, and they might want to share certain resources with each other. So you can then obviously, again, implement that interface and allow, again, other little services that are logical services in your microservice to kind of utilize that as well. And this is an example of building out a little gRPC client. So it has a constructor and it implements those functions. And then the next thing is, so now you have a client, or you have something that implements the interface, so it's an existing client, a gRPC client, and you have your messages that you're going to be transporting over, that's your profiles. as well as the RPC server calls that you're going to be making. Now you need to build the actual server that will handle that requests and actually fulfill them and give a response. And this, what we do is we go and create a server package, and in that server package we go and place a little server Go file and define all the resources in that struct, all the resources that we want to have access to, and again have a constructor and then implement the functions that we want to have. Again, in this case, you don't need to have a one-to-one mapping again with the client or the interfaces functions, because essentially the server could have other types of functions, and the client itself could choose which functions to pick from the server to fulfill the requests that it needs to fulfill when getting an order or something. But this again is just a little sketch of how it could look like in a simple environment, in a simple case. And then again, can show you the DB and ops packages that we then chose to add. So we chose to then, if you have a microservice, we chose to then maybe add another package called DB. And in this package, we want to have all the sort of database operations that we want to perform, like getting the number of orders there are, selecting certain things from our actual database tables. And on top of that also, we wanted to have a ops package, because sometimes above and beyond that, like some of these calls aren't just necessarily just raw, database calls. There's certain sort of workflows that we need to take into account as well, certain strategies that we need to make, like a little business logic layer would provide. And that's why we decide to kind of have this sort of ops package thing. So potentially could call it a DB function or another third-party API and string the results of that together to then produce a result that could be of use. And then we later then discovered that there's this cool package, cool thing from Go. There's this internal package. And the internal package is a nice thing because it allows you to, I don't know if everybody knows, but like in Go, when you want to make something public, you just put a capital letter in front of it, like a function with a capital letter or a variable with a capital letter or something. And that automatically means that it's accessible from outside of that package. But if you also want to still have that as an accessible thing, you can stick it into like an internal package, and then everything in the internal package can kind of see it and pry into it. And everything like one step above can also like pry into that. But everything then outside of that can't. So it's quite cool to have such a thing, and Go introduced that a little while ago. And we then started introducing that and started thinking, okay, so what are cool candidates that we could potentially move into this sort of internal package? Ideally because, again, monorepo, and we don't want other guys having access to our microservice to accidentally invoke a function that they're not supposed to invoke, and this kind of on the language level kind of prevents someone from calling something because they'll get a complaint about it, and that's quite cool. And then we introduced a CMD package, and that is for where all our sort of main functions would want to live in. So there could be multiple sub-packages underneath that, and in there define multiple main functions. So maybe you want an HTTP server, you want a different binary for like running background jobs, or you want to do different things, and you can all stick it underneath CMD. So in a nutshell, I decided to kind of taking into that internal package and into consideration, and kind of considering which things to move into internal. DB and ops seems like a good candidate, at least for now, in our opinion. And this is sort of an end result of how a microservice at Luno kind of looks at the moment. We feel that it's kind of simple and easy to kind of understand, without having like too much strain or too much issues around it. And from this sort of service that we have, we're still on that evolutionary path, right? We haven't yet we still have some monoliths, and we still have this monolith that we're slowly chipping away. And which is quite cool to be in this kind of phase where we're still chipping things away. And I think we at the moment have like 27 microservices set up in this sort of structure, and they're counting on a kind of rapid basis. Yeah, so along with the structure, we want to kind of continue to span out these new services as we both scale our team, as we both scale in terms of our actual customer base and customer numbers. Because at the end of the day, for us at least, it doesn't make sense to kind of, from day one, build a system that kind of scales and can handle infinite amount of customers or infinite amount of whatevers, when you don't even know if the product even makes sense to a customer. And at the same time, as the organization grows and scales, if you still have a small team, again, it might become a lot of load for you guys to kind of build these things up and then at the same time monitor it and at the same time try and handle all these thousands of microservices if you're still a small team. So for us, we kind of want to continue with this growth to kind of be in line with our staff count, our engineering count, and kind of make it kind of make sense for us. So I think key takeaways with this again is, for us at least, and I hope this kind of makes sense or resonates with any one of you guys here as well, is to try and start, if you want to start and build an idea and seeing if it want to make sense in this world and if there's a customer base, try and potentially start with the monolith and see where the frustrating pain points are in your system and try and break that up into bounded context, into little black boxes that serves a single purpose. And then give that a chance to run and see if that actually improves your situation. So again, thank you very much. Yeah. So yeah, any sort of questions from anybody?
Any questions? No questions?
I have one.
Oh, you do? Yeah, sorry.
Thanks for a great talk. Just one question. Why did you decide to use gRPC protocol instead of going with more event-driven architecture, developing your microservices?
Yeah. So part and parcel of the decision was, as I said, after noticing that we had this sort of bottleneck with our database, we did a little bit of research. And a lot of people in the community were saying how amazing gRPC is, how on the first hand, it allows you to kind of define a nice message that you're going to be transmitting over the wire, so to say. And it also offers this sort of nice interoperability between the multiple languages because it supports all these awesome languages. And by that, and also not just that, I mean, it's also lightweight over HTTP2. And because of that, we kind of thought that it's a good idea to go down that path. Yeah, I don't know if that answers your question. So the benefits, I think, for us is, or at least why we looked into it, is first and foremost that you have a central definition of what you're transmitting over the wire. It's centralized. You don't need to do all the funky stuff with sort of JSON where you're trying to marshal and unmarshal and like you focus your time on kind of converting sort of a string to some sort of object. But rather your proto is your sort of your definition, and there's some cool tools to like auto-generate those sort of definitions for you in Go code, and that's about it. And obviously on top of that, because it uses HTTP2 and also the fact that just the way it's set up in essence just makes it a little bit more faster, not having all that sort of bloatedness or a lot of metadata describing stuff and all of that. So it just makes it a little bit more faster, that binary encoded data. And that's kind of why we went down that path, I think. I hope that answers your question. Yeah. you could probably. What's wrong? Okay.
So you guys were using, you have a database and ops.
Yeah.
But if you wanted to have like a kind of a transaction that went through several ops, how are you handling that without like returning a transaction from the database?
So must I repeat the question? Yeah. So you're asking, we have database and we have ops, and how we pretty much propagating transactions between our database, the different queries that we want to execute. So in essence, like in our case, again, it comes down to just our simple paradigm of trying to solve things and trying to, once we get a sort of, like our approach to all of our engineering processes is try and do something, and if that fails, move on to the next thing, and then try and find a solution for it. So what we have in our instances, because we use MySQL, and what we tend to do is, so from the ops package, potentially, you could start up a transaction, and you could then pass that through into your DB package, and it can then obviously perform what it needs to perform, and then move it on to the next ones, and then at any point in time, if it tries to commit or roll back, it can do that. So it's this sort of one transaction that gets then spun throughout in the context of the microservice that's from that call from ops. That gets passed around through all those sort of different DB queries, and then at the end either committed or rolled back. Yeah.
Cool. I think we're done, Chad. Thanks so
Yeah.
much.